cool to have a lot of folks over here and also dialing in. Grain, we can start the recording. I think you just did that. Awesome. So I'll give you a bit of a background information about OpenLineage very briefly, and I will talk through some logistics for today, and then we'll start right with the presentations. So I'm Jens. I'm with the Google Cloud Dataplex team. We do quite a bit of work on Lineage and with OpenLineage as well. Gabrisha is helping with the organization, and Michael Robinson, he's the community manager for OpenLineage. He's also helped us set up this meetup today. He's also on the call. Hey, Michael. So in terms of the agenda, so we'll have Augusto talking about Composer, OpenLineage integration with Dataplex first, and then we hear from Kacper about Airflow, how to add OpenLineage support for those Airflow operators. Tomasz is going to talk about how do we test the compatibility of OpenLineage producers and consumers. That's quite an interesting topic, I think, since the ecosystem is growing quite fast. Then Maciej and Paweł are talking about some observability topics. We'll find out what exactly that's going to be like. And then at about 8:30, we are going to close. And yeah, emergencies. We are right next to the emergency exit. If anything happens, we will walk down the stairs across the corridor to the ground floor. The emergency number in Poland is 112, I think. But I hope we don't get there. In terms of ground rules, so you have to wear your badge at all times. You can walk around in the event space here. And if we happen to go outside of this space, then some Googler will need to walk with you. You are allowed to take pictures or videos if you ask, but it shouldn't include any or must not include any need to know or confidential information, but you will not find that in here, I guess. Maybe the Wi-Fi password. So take care a bit of that. And we'll take some pictures so we can post them later on some OpenLineage website, for example. And also the presentations are going to be recorded and they will be published on YouTube, I guess. GetInData, which is part of CBR now, is inviting everyone afterwards for some drinks, alcoholic and non-alcoholic, in Fabryka Nowlina, Uwaga Piwo. We had that last time around as well, which was really nice talking to folks. So I really recommend you join. Any questions to that part? No? All right. So OpenLineage, for those of you who don't know what it's about, it's trying to solve this problem that there's an ever-expanding ecosystem of data processing, data orchestration systems that do transform data, that do lead to data being moved from one place to the other. And at the same time, a whole set of consumers or potential consumers that are interested in that information, lineage information in particular. And so OpenLineage is standardizing on the message format for exchanging lineage information between those producers and consumers. And that, I think the main benefit of that is going to be that those folks developing those producers or consumers, they can really focus on the business logic more than integration between different producers and or consumers. OpenLineage was originally very much focused on capturing operational lineage, so capturing that information at the point where data transformations occurred, but they have more recently moved into also supporting what we call static lineage or declarative lineage, so specifying lineage relationships and publishing those at a point where maybe a transformation hasn't happened yet, but maybe a SQL script has been parsed and lineage information has been extracted before it's executed. And so the data model is very much based on this run event, which you can see here. So that's for the operational lineage, which transfers information. Michael, yeah, that's being recorded. So each of those OpenLineage events transfers information about what is the job that was run, that the specific execution, so the run of that job, and sort of the event itself, the the inputs and outputs that were being read and being written. And that's all defined in a JSON schema spec. So actually a very lightweight standard. It's also very extensible through additional assets that can be attached to all those three aspects mentioned here. And so it's quite widely adopted already in industry by now, actually, one can say. And within Google, we have also started more relying on OpenLineage as the model to integrate systems on our end. And that's in particular two producers, Datadog, which provides managed Spark, managed Hive. So those come with OpenLineage support now. Cloud Composer, which we'll hear more about, is about to make that switch to OpenLineage. And we have the Dataplex as the data governance solution in GCP, which accepts OpenLineage events. Not only from those systems, but more general also. If you do your custom integration, you can do that as well. And Dataplex is more moving into BigQuery, actually, so that's where you normally would look at lineage information. If you want to get involved with OpenLineage, there's plenty of ways. It's actually a very welcoming community. You will also find that a large part of the community sits actually in Warsaw, or like Poland in general, not Warsaw only, but in Poland. And there's plenty of ways getting involved with it, like the regular technical steering committee meetings, for example, or just joining on Slack, GitHub, etc. Yeah, and that's it in terms of a very brief introduction. We'll hear more about OpenLineage in the next 2 hours or so. Any questions up front? No? Augusto, you want to go?
Why is it so small? Do you know?
You want to use my screen? Can you read this?
I think some parts are going to be.
Okay, because of some one. Okay. Can you go to the slide?
Maybe. Let's try again. Here, okay. Okay. Hello, everyone. My name is Augusto Hidalgo. I'm part of the Cloud Composer team here at Google. And yeah, today I'm going to talk to you a little bit about Cloud Composer migration to OpenLineage. So TLDR Cloud Composer now uses OpenLineage for the data lineage integration, with some small asterisk there that for now it's in some regions is currently it's being deployed right now. It's being rolled out partially, but yeah, there are already some regions which fully use the OpenLineage for the data lineage integration. So the agenda will be. People from Google know what that means. Okay, thanks, man. Yeah, okay. So the agenda will be, we will talk a little bit about the previous integration, the new OpenLineage integration, and some possible improvements that we can make. First of all, what is Cloud Composer for those that might not be familiar? It's a fully managed workflow orchestration service built on top of Apache Airflow. Apache Airflow is an orchestration platform which is used heavily in community. It's an open source platform that allows you to write, orchestrate, and monitor different data pipelines. Is used for business operations, for ETL and ELT pipelines, and for machine learning workflows as well. So yeah, Cloud Composer was already integrated with DataLineage. We provided a DataLineage integration for already, I think, maybe 2 years or so, but it was based on a custom implementation. So we used a Lineage backend, which was the main interface that Airflow provided to emit Lineage within Airflow. And this custom Lineage backend was the one that was building and sending events to the DataLineage API. And so in this integration, we had to implement basically everything for any operator we wanted to support. We had custom logic for generating and also generating the inlets and outlets, and also transforming them into a format that the DataLineage API could handle. So yeah, this had a lot of pain points. In general, it worked fine, but there was some pain points, and specifically the operator's code was not tied with Lineage logic. So anytime the operator's logic would change, they would, for example, our Lineage integration will depend on a field of an operator or the format of this field, and then in the operator, the field will be changed, the field will be removed or renamed, whatever. Our Lineage integration will break because there's no really a connection. We were just depending on the operators to behave a certain way. So that was obviously a limitation. And also we have a limited support for operators. We could, for every operator we wanted to support, we had to implement the custom logic, which would extract the inlets, the outlets. And of course, with the first point, the more operators we support, the more they break, and the more we struggle to support them. So now the OpenLineage, basically we decided to switch to the OpenLineage integration, which is already natively supported in Airflow. So why? Well, in OpenLineage, the logic for the Lineage generation is tied to the operators. So we don't have this problem anymore. Anytime the operator changes, the logic will be updated as well. When customers, for example, install different versions of the operators, then also the Lineage logic will be automatically use the right one. And of course, we have efforts coming from a larger community. It's not only Google. We adopted a standard, and we support a larger number of operators. Previously, we were focused mostly on Google operators, but now since it's an open standard, we also support many operators coming from different providers package. And clients wanted OpenLineage in general. And in general, we will deliver users all the benefits that come with OpenLineage integration, including, for example, hooks Lineage, which is something very cool. So about the implementation, just a quick overview. Basically, we just had to implement a transport for Composer. This transport takes the events emitted by the OpenLineage providers, which is a plugin, Airflow plugin, and sends these events to the DataLineage API, injecting some Composer-specific facets to. The main part is the transport, but we also deliver a extractor for Dataprog, since we have a specific logic before, and this is not in community, to provide backwards compatibility, we have a structure for Datadog operators, and we provide some convenience dataset classes, which are just a pretty way for customers to annotate lineage manually if they want. So here we have a small example. This is a part of a Airflow DAG. We have two tasks. One is BigQuery insert job operator, which runs a simple query. And we also have a bash operator, which is manually annotated with these convenience classes. Users don't have to do anything else other than enabling the data lineage integration. Once it's enabled, the Composer environments start emitting automatically the lineage events. So, for example, in this case, when this is run, it will automatically report the lineage. Here, we can actually go quickly to how it looks. So once that is run, we will get this lineage information. This is the data lineage UI, and these are Composer jobs. And yeah, we will get the connections, the relationships between the data sets. We will have the runs. We will have different specific Composer version, Airflow version, the environment name, etc. And there's also ways to go here to, for example, the DAG in Composer, which will take us here, yes. And for example, here we can check. We have logs for, we have redacted logs of the event that was sent to OpenLineage, so users can easily see the inputs and outputs that were sent to the OpenLineage data lineage API. For some reason. Okay. So the logs that are visible in Airflow logs are basically this. There are a redacted version of the message that was sent to the data lineage API. It includes the inputs and outputs, and it includes some specific Composer information. About the migration approach, so new environments or environments that are updated to newer versions will automatically start using the data lineage, the OpenLineage integration. Environments that were using the data lineage integration, it will simply switch to use OpenLineage now. This is more or less transparent to users. They cannot, let's say, choose which integration they use. They will automatically use OpenLineage. The user interface is exactly the same, so how to enable or disable or anything else is the same as before. Now the difference is under the hood, it uses OpenLineage. And it's being gradually enabled. Currently, it's already fully rolled out in 7 regions. And yeah. As previously, the integration is automatically enabled for any new environments that have the data lineage API enabled in the project. The environments will automatically start emitting lineage. And some small feature improvements that we have in mind are one that is easy, and I would say kind of necessary, is an easier way to tell which operators are supported for a given provider version. right now it's only easy to know which operators are supported in the latest version of the provider's package, of the corresponding provider's package. So yeah, just documenting this on let's say on each of the provider's version would be very helpful, because in reality the customers are not always using the latest version, and they are sometimes downgrading or upgrading. So it's for them it's not obvious to know that they would need to check the code of that version of the provider. So yeah. And we also have in mind some better integration with other GCP products. For example, BigQuery integration. We have some plans to make more obvious with which jobs from Airflow to BigQuery or from Dataplex UI to link those products. So yeah, that's pretty much it. Thank you. If you have any questions. Yes. Yeah. Okay.
So as someone who's interested in making OpenLineage as easy to like produce, consume, was there some particular thing that you maybe didn't like or had some issues with that we can improve? And to balance things out, one thing that you like and was, very easy to do.
But sorry, do you mean me as a user or as someone that?
As someone who worked on it.
Yeah. Okay.
Maybe wrote this composer transport.
I would say the integration right now it's way cleaner than before. It's way thinner. We just need to maintain the transport, which is way thinner than before. So for sure that's a plus. On the downsides, I mean, of course, we have less control now. Since it's coming from a packaging community. Say we want to change something, it's not as quick as before, but at the same time, we're benefiting from all the features and improvements that are being made there. Yeah, I think, for example, when we find a bug in, let's say, the lineage logic for an operator, the whole fixing and rolling out now it's a bit longer or more difficult to make it quicker, because we need to commit it to community and wait for a new provider's version, and then we can integrate it. We can of course get around that with using custom extractors, which is something that was very useful, and it's probably going to continue to be useful to have the possibility to use custom extractors.
Maybe to add to that, I think the biggest problem I've noticed was that we can't actually update the OpenLineage provider for older version of Airflow. So once it's 2 years old, I think Airflow drops the support. Mm-hmm. And then we're stuck with some old version that will have this bug forever, right? So Airflow 2.7 users can't expect to get this lineage updated, right? And you can fix it with custom extractors, but
yes,
yeah.
Exactly.
One big thing that I also to add on the good things is the memory consumption compared to the previous lineage backend feature in Airflow, which is way lower. So we observe that.
Yeah, no, that.
So I have two quick questions. First, are you using the vanilla OpenLineage provider, or are you using some Google modified version of it?
So far, vanilla.
Nice. Okay. So second question, because you mentioned the composite transport that you're using. So what happens if a user want to use their own transport? Are you allowing that, or are you using the? Yeah, how does it work? Can we send this to two places, or for now it's locked to the one that you configure?
Two places, not exactly. Customers can use their own, but of course this falls outside our supported integration. So, but yeah, they can override this configuration and use their own transport.
But But can they use like dataplex and something else, like or if they overwrite it, they're
For now, if
losing.
they overwrite it, it will just report to where they send it to.
Okay. Thanks.
Any other questions? Okay, cool. Thank you, Augusto.
Thank you.
Kacper, you next. Yeah. It's getting better.
It's working.
You don't need to worry about this either.
Okay. Hi everyone. I didn't I looked at the agenda and it didn't appear to me, but it makes a lot of sense to do my presentation after Augusto, because right now I'm going to talk about actually how to support Airflow operators. And I think in every meetup there should be a very intro level talk, and this meetup it's mine. So if you're already a power user of OpenLineage, there will be just maybe a few interesting things for you. But I think if you're not an expert, then you'll probably find something useful here for you. So I'll quickly talk about operator level support, how to implement it. I'll show you some examples, and I'll go through best practices. Then I'll show you how easy it is to test them. And this is also what Augusto mentioned, because we're part of we're an Airflow provider and we're part of the code base. It's really easy to have unit tests integrated into the code base, so we don't have this problem that the operator changes and the lineage falls behind. And then I'll show you a quick feature about what we did for Spark operators, and basically show you that implementing OpenLineage support does not always mean you need to emit some lineage events or even lineage metadata. And then if we'll have time, I'll talk about Clever Lineage. And if you want to know basically what OpenLineage is and you want to get the very basic, there's plenty of intro level talks on the OpenLineage website. So I'll invite you to watch them. All right, so enabling OpenLineage is really easy. So you install it, you configure the transport, you just tell us where to send the events, and it's happening. And what next after you do it? So you can use already supported operators, and I've checked yesterday, and we have over 50 of them right now. So I think it's a nice score. And as you can see, and I'll probably maybe I'll show you as well, a big part of them are Google operators, because you can see there are some hooks. No, wait, there are some hooks below, but also just plenty of Google operators, and then just some from other providers and some common operators as well. But let's say that you don't want to use, you have some custom operators that you use. Then I'm going to show you how easy it is to add your support to it with just adding a single method to the operator. And also something to remember, because you've probably seen okay, we support over 50 operators right now, and there's probably hundreds of them in the Airflow code base, but not every operator needs to have lineage. So if you're using some Slack operators, you're using some, I don't know, operator to create a VM or something, it doesn't need lineage. So there's only a subset of operators available in the code base needs lineage support. So what was the idea behind this implementation? How should operators expose the lineage? So it was very important to keep this code inside the operator because of the problem that Augusto talked about. We don't want the lineage to fall behind. So the OpenLineage provider provides the operator lineage structure that the operators can use to expose the lineage to the provider, and then later it will be used to build the OpenLineage event. And then we can emit, expose lineage on start, complete, and fail states with different methods. This is the thing I showed before. So this operator lineage structure, it has inputs, outputs, which are the data sets, and each data set can have plenty of facets of their own. Then we have some facets that we can attach to run and some job facets. So you might be asking yourself right now, like, why not emit full lineage from the operator? Why the operator should not be, giving us the full OpenLineage event, which is way more than these things here. And it's because we're doing a lot of heavy lifting behind the scenes. We're adding a lot of common metadata. We extract it from Airflow in the provider, and then we attach this to the full OpenLineage event. So you can see here that like task metadata, so the thing that we extract from the operator is only a part of information that it's included in the OpenLineage event in the end. So we just get whatever is operator specific from the operator, and then the rest we extract in the OpenLineage provider, so that it's way easier for user to implement the support. Here's the architecture, like how it works, how this is maybe just for like a reference, because I haven't talked really about the listener API and how it works, but OpenLineage as a plugin implements the listener. This is basically a thing in Airflow that can listen for specific events, and this is how we know where the task started, where the task finished, and same for DAG. And this is what we use to like send the events in the right time. Yeah. So the OpenLineage methods, I'm gonna come back to it and then show you some examples of how it's implemented. So there are 3 of them, and as you can see, the onStart method is being called before the operators execute. So it's being called at the very beginning. And sometimes it's enough. Like if there are some simple operators that do some simple data moving, you already like moving from like one GCS bucket to another, you already have all the paths. So you can send this lineage metadata even before the actual operation happens. But then if it's not the case, if you need some metadata produced during the execution, then you have the onComplete method and onFailure called respectively when the task succeeds or fails. So then, for example, if you want to include some BigQuery metadata of a query, like how many rows it produced or something, then it can be done because you can save this information and then use it in the OpenLineage method. So this is an example of this like simple implementation. This is an onStart method of GCS file transform operator. And as you can see, this is really a simple operator that it's taking one file, transforming it, and outputting one file. So the simple implementation is like one input data set, one output data set, and we can do it even without tasks execution. This is a really simple implementation of the onComplete method. And we usually note like why we implemented onComplete, and here it's because there's some pre-processing on paths, for example. So if the operator is already doing some heavy lifting or like parsing the paths, then we usually take advantage of that and implement the onComplete method. And now let me tell you about some best practices, and then I'm going to show you some more complex example of the BigQuery insert job operator that Augusto showed here. When calling it is actually really simple, but then you'll see that extracting lineage from it, it's not hard, but it's complex because of how complex this operator can be. So let's say you're implementing your own methods. What to watch out for? So you should probably use, you should import all OpenLineage related objects locally in the method, because OpenLineage it's not mandatory for Airflow users. We don't want to cause any import errors. So for example, if we were to import from OpenLineage provider somewhere else and somebody don't want to use OpenLineage and didn't install it, then we'll cause import errors. So this is very important, but it will be probably caught by the tests in Airflow repository anyway. So it's hard to break, but I did it once or twice because of like how complex it is, the cross-provider dependencies.
Second really important part is to use OpenLineage compliant dataset names. So because Lineage is built on this correlation, we need to make sure that every producer is naming datasets in the same way so that the backend can't connect them. So there is a naming convention on the OpenLineage side, and it's very important to use it because then if you, for example, if you don't conform to it and you name your dataset in a different way, like a GCS file, if you name it in a different way, then on the backend you won't be able to see the lineage because it will not be able to connect those dots emitted from different places. Then also, like I know we talked about like how that OpenLineage is not like heavy, is not putting a lot of computing. So this is also one thing to watch out for, that we should avoid work on execution of the tasks because also of the users that don't use OpenLineage. So let's say that we're executing some BigQuery queries and we want to ask BigQuery for additional metadata so that we can include them in the OpenLineage event. We should probably save the query IDs in the operator and then ask for this metadata, like query the actual API in the OpenLineage method, because I don't want to execute these calls in the execute method, because if somebody is not using OpenLineage, then we're basically wasting their time there. I'm going to come back to it, and this is all related to the thing I said before. I also stumbled upon it a few times trying to debug why my lineage extraction is not working. You need to adjust for deferrable mode. So if the operator goes into the deferrable mode, most of the attributes are lost. So you need to reset them after you come back from the deferrable mode. So for example, if you want to save, this is why we should not save like very complex structures as well, because then you have to like send them to the triggerer and then get them back. So only like job IDs or something very small makes sense there. And coming back to this, as I mentioned, there are free methods, but you don't need to implement them all. You can choose one of them. You can implement all of them if you need, but usually one of them is enough. So if you already know everything before the task execution, the onStart method is enough for you. But if you need some execution metadata, then implement onComplete method. There's like a whole logic described in the OpenLineage provider documentation, like what happens if you don't implement some specific methods. But basically, we'll call the one that is implemented, and we'll try to use this lineage metadata. Okay, so now the promised example of the Google provider. So this is one more, a bit more complex. Oh, wait, let me maybe enlarge it for you. This is a bit more complex. This is like, wait, let me 293. So this is like 100. Yeah, not even 100 lines.
Oh, you have the screens here so you can see well?
Yeah. So it's not that it's not really important like how what exactly is happening, but we're producing some we're extracting input-output data sets. We're adding some run facets, for example, with the query ID we get from BigQuery. We're pre-processing some paths, like for example, with the wildcards. We're asking for schema. So for example, if this is BigQuery to GCS, so we can ask the BigQuery like, hey, what was the schema of this table? And then we can attach it to both the BigQuery dataset and the GCS dataset if we know that it hasn't changed. Yeah, but I think this is the most complex operator that is supported right now. This is BigQuery insert job operator. You can see like it's almost 600 lines of only the lineage extraction, because this is we needed to like move it to a separate mixin and the file because it was like too complex to be in the operator. And this is because like this operator can run 4 different types of jobs. It can like load, copy, extract, and just query, right?
So we needed to adjust for it. And also, I think that was added a few months ago. We get the table level lineage from BigQuery, but then we also have the SQL query. So we're also adding the column level lineage based on SQL parsing. And I think this is like half of this code is making sure that it works properly. So it can get complex, but the implementation itself, like of the lineage, is quite easy.
You can also have child jobs.
Oh yeah, and you have child jobs, which is also fun. Yeah, and we had to adjust for that because if you have a script job on BigQuery, it spawns child jobs, and then it gets fun as well.
How are you tracking those?
Let me find it. But basically, we're like extracting lineage from the child jobs, but then we are just emitting everything in a single OpenLineage event, so we don't get this lineage per child job. But I think this is like a feature to come because we implemented this. I actually merged it like I think yesterday or 2 days ago for Snowflake. When running Snowflake queries with SQL execute query operator now sends a separate pair of OpenLineage events per query run per statement, and I think this is something we'll probably want to implement in BigQuery as well, so that you get the even more detailed lineage, so you know exactly like which statement costs like what lineage. And yeah, but BigQuery is way better in this case because it actually like connects the child jobs. Like the child job has the parent job ID, and it's easy to like track it together. In this SQL execute query operator in Snowflake, it was not that easy to correlate these jobs. Okay, no, this is for Spark. Okay. So testing OpenLineage. Do I have some time? Yeah. Sorry, what? Merging for Spark?
Unfortunately, it's not. So, I mean, I think the question is about it for a single Spark application, several lineage events.
So as I understand, the Spark question relates to the fact that the Spark application has several Spark actions, and each action is treated as a separate run, and there are a lot of events coming from a single application. So if the question is about this, then yeah, so far, merging Spark events, it's not supported. Oh, I'm correct. Yeah, so it's not supported. Yeah, but there is a transform transport added, and you can create your own transformer class and do some kind of aggregation if you like. I think the community didn't want to support it because we tried to keep the integration stateless, and storing the events, they have to be kept somewhere, and it will break this assumption. So that's the reason for having it. Maciej, am I right?
Yeah, I wanted to add like doing more stateful operators, stateful stuff in the integration introduces possibility of like out of memory errors and those kind of stuff, and lineage should not break your jobs. So I think unless we have some good idea how to do this and to not cause any errors, then we'd rather maybe not implement this in Spark operator, Spark integration.
Yeah, I think this is a really good motto that we should probably print out, like lineage should not break your jobs, because yeah, I did it once or twice. All right, so just a quick recap, like how to test OpenLineage. So since we're part of the code base, it's really easy. We just add unit tests. Wherever the operator is tested in Airflow, you can add unit tests for the OpenLineage method. In this case, for example, the get OpenLineage events on start, and we just check if the operator lineage has the data that we expect it to. And it's really easy. It's really good, like, to be a part of the code base, because if somebody modifies the operator, the test will fail, and then you'll also need to adjust the lineage extraction logic. So the risk of like lineage falling behind is really low. Yeah, and also for the on-complete methods, it's the same. We just mock the execution of the operator. Yeah, sometimes it's obviously more complex if the execution is really complex and if there is a lot of like metadata needed for the OpenLineage. then the mocking is maybe more complex, but generally it's also doable and it happens. So now maybe just a few slides about like how can we help Spark users. And this is what I meant, like implementing OpenLineage does not have to actually emit lineage from the operator. We can also like help by help configuring Spark jobs. And because people use, for example, Dataprog and trigger it from Airflow, and we know how this Dataprog job is configured, we know how how the Spark is configured underneath, so we can inject some properties that will help configure OpenLineage. And this is what we did for a few operators for Dataprog. So before it was also doable, but you either had to use like OpenLineage provider macros and had to modify the job themselves. Right now they can do it with just a simple variable that will inject either parent job information for the parent run facet or transport information, so that they can configure the same transport that is used in Airflow in their Spark application. And I can show you the proof. It's not a lie. This is the main branch, and this is the Dataprog submit operator. So here we are modifying the job if somebody is using those two flags or any of the flag. Yeah, can you zoom in? Yeah. So if you choose to pass the OpenLineage flag here, then we're going to modify your job. But we're only inserting the properties, and there are a few safety switches there to make sure that we're not actually modifying any of the of your important configuration. We're just checking for the properties, and if there are any like OpenLineage properties there already, we're also not going to override them. We're just going to log in a warning and tell you, hey, we didn't automatically override your precious configuration. And for the next steps, maybe we'll be able to fully enable the OpenLineage for this part, because right now these two things, like providing the listener and the jar, is still on the user. But I think it's doable. It's way harder, but I think it's doable. Yeah, maybe I'll just finish it here, because I could talk about hook level lineage way more, but this is just a teaser that if you are like more experienced developer and you're writing your own hooks, you can also implement lineage into your hooks, and it's available since Airflow 2.10. And as you can see here, this is an example of BigQuery hook. There's a hook level lineage connector where you can just add input-output data sets, and then OpenLineage will collect that as well and use it in the OpenLineage events. There's some overhead there. You need to also, because the data sets collected are not OpenLineage data sets, they're Airflow data sets. There is a translation layer. But as you can see, this is also easy. This is all the code that was needed for this BigQuery hook level lineage to work. So it's not that complex. And I think that's everything from thank you. Does anybody have any questions? Yeah.
Thank you for the talk. Does it work?
Lighting green, right?
Yeah, thank you for the talk. I have a couple of questions. First, Augusto mentioned that more integrations with operators obviously means more support. I get your point with unit tests, but probably it's not 100%. So how do you plan to address support for so many operators and maybe a growing number of them?
So there are also, they didn't fit into the presentation, there are also system tests that are in the Airflow repository that anybody can run. And I know that OpenLineage has their own system tests, but I know that in Google Provider as well, there are system tests for Google operators. So that, the unit test coverage is pretty strong, I would say. I don't think there is an operator with Lineage that don't have it tested, but obviously it won't test the full integration end to end. So I think I think system test is a good start.
Yeah, but system test not run by CI, at least for community side. So it's up to user to recheck, up to community to recheck and raise issues if any problems.
Yeah, I think this is something maybe worth addressing in Airflow community. Like we can probably discuss whether or not, or how to make system tests run more often.
Yeah, I think it's pretty fresh.
Yes, we are going to have a
Yes.
discussion about that.
I know. I was looking at you like when.
We are going to have a discussion about that for Google provider, at least with yes, with people who are here in Google, and yes, in the community, we are thinking about making it more often, or at least have a way for contributors to be able to ask someone to trigger the documentation, the build for them without them having to configure that, because it's not very easy to run all these tests at all PRs and make sure that they are green, because those tests are usually kind of flaky, not really always 100% working. So that would be a bit of a distraction, and also it costs, of course.
It requires some infrastructure actually. Yeah. Maybe you have more. So yeah. I don't know.
I can add one thing to those system tests. So some time ago, I implemented variable transport OpenLineage that allows you to basically send the event to variable transport and some check operator that would later check the lineage. So if you're running let's say Google system tests, right? You add this operator to the end of your system test DAG, it can check whether the events emitted by the previous parts were valid, right? So you can integrate this into existing system tests. But the one thing is true that they are not running automatically right now. Oh, and there's one more disadvantage. You won't check the DAG level events because the operator runs before the DAG ended, obviously.
Also, I have a second question about hooks. You mentioned you point to integrate. So do hook integrations will eventually replace operator integrations, or they will live in parallel?
I think they will only supplement it because or maybe replace it, but for some simple operators. But usually when we're in the operator, we have more context about what's happening, and we are able to provide, I think, more metadata. Maybe not in this, in simple cases, but I think still it will be beneficial to implement it on the operator level because of how, because you know basically what's happening. But yes, I think there will be cases when the operator level support will not be needed because we know that there are hooks needed underneath. So we'll just write the test to make sure that these hooks have the support. But I don't know. Yeah, that's my opinion. Yeah.
Okay, thank you.
Hard to imagine hooks Lineage to replace BigQuery insert job operator. Yeah, exactly. If you have a BigQuery insert job operator with some extraction logic, some complex one, then hooks will probably not replace it. Yeah. Okay, thanks a lot.
Are there any questions on the call? Maybe any of the hybrid attendees?
Chat looks clear, so.
All right, then Tomasz. Yeah, cool.
Okay. Yeah. So, hi, I'm Tomasz Nazarewicz, OpenLineage commenter from GetInData, and today I'll be talking about the question that has probably been asked a lot, just not in this specific context. So, are they compatible? And there is this little repository, and is that not working? So wait a second, slides. No. Yeah. Yeah, so there is one little repository in OpenLineage project that was recently added that tries very hard to answer this question, but we'll circle back to it and let's go back in time for a bit. So what were the motivations here? So like there is a question if something is compatible with OpenLineage. Is it an important question? Well, it kind of is, because, well, it's good for a standard if many things support it, and it's good for a technology to, well, basically display that it can support the standard that that many other things display, because it's an obvious choice if somebody already is in that ecosystem. And in OpenLineage, we kind of fall short in that category, because, well, we have this pretty list of logos in our ecosystem webpage, but it doesn't give you that many information on what is the level of this of their compliance with the standard. Like if you would like to know, well, if something, what facets something supports and how it compares to something else, you just have to basically search it yourself, right? Also, there is no real criteria what it, like, intuitively we know, but formally there is no criteria what it means for something to support OpenLineage, and that made some people think a lot, and the result of that thinking was creation of the doc for defining an integration certification process for OpenLineage. And basically what it did was outline what do we expect from compliance testing, what would we like to get as a whole community. And we can basically split ourselves into two parts. The vendor part, which would like to basically handle if my product is compatible with OpenLineage, and the community part, which basically has its interest in if OpenLineage is compatible with everything else. And let's see those requirements. So what the producer wants, they would like to know if what they produce is compliant with the OpenLineage spec. If not, they would like to know exactly where, like what field is wrong, if something is missing and it's required, if the type is not correct. Like they would like to know it all. They would also would like to be able to, like, basically that's I think for every user, if you want to test something, rather than submitting it somewhere, like with some procedures, you would like to be able to just run it on your machine and have a quick test and be done with it. So this is something. And last thing, if we would like to get somebody to contribute like their test scenarios and stuff, we would like to make it as easy as possible. For consumers, it's, well, basically the same. They would like to know if they are if they can consume OpenLineage messages in different versions, and also because OpenLineage is backward compatible, but it doesn't mean that if you can read right now, like the consumer logic for ingestion can be different, so it can just stop working. So they would like to know that. Other thing is, well, you would like to know which producers you can handle as a consumer. And two other things, just like in the producer case, they would like to be able to run it locally, and well, the adding tests should be easy. On the community side, well, the users, they generally would like an overview. They would like to have an easy way to see what is compatible in what extent with OpenLineage, and how much information can they get out of it. For users, it would also probably be helpful to have an example of how to set up something with OpenLineage, and if it can be shown in the tests, that's also very good. Also, it may be kind of important to see who in the community is responsible for the specific components. And as usual, running locally, big plus. And the last ones, the developers, committers, so us, they would like to know if they make the change to OpenLineage spec, will it break something? And it's usually well tested, but who knows, there may be some corner cases. And even more than that, it's good to have an early warning system. If there is a new release of some component, you can have automatic tests for it, like to just try to extract the lineage from it, like from the producer, or if there's a new version of a consumer, try to sending the events there and see how it goes. Again, seeing for a maintainer, it's even more important to see who exactly is responsible for the test scenarios. And developers, more than anyone, would like to be able to run the stuff on their machines. So basically, this is a quick summary. Some of the requirements overlap. And based on that, we created implementation goals. I mean, we didn't create this list. We did a whole design doc, but we're not going to go through 10-page documents. So basically, what we had was, if we want to publish the information, the compliance information, then we need something where it can be visible, which would be, for example, the OpenLineage website. And we need data, like the information that we can basically, from where we can compile this compliance information. So we need to generate the reports from the tests, and we need to run tests to get those reports. And about testing, the testing should be about more than generating those reports. It's also for checking this backward compatibility for the developers, and we need to have tests if somebody wants to add something new. So checks for the PRs, that kind of stuff. And of course, the more scenarios we have, the better for the tests. And to encourage the community to participate in that, we need to basically make it as easy to extend or understand as possible. That means whatever we can make reusable, we should make reusable. If we have producers or consumers that follow a single convention, single structure, it's always easier to add something new if you already have a model to work on. The scenarios should be well described, because sometimes, for example, you would like to use some parts of some basically, if you want to add new scenario, you would like to have a description of what is happening everywhere, so you don't have to basically reverse engineering stuff. And in case of consumers, it's often like they have their mapping, how they will take an OpenLineage event and map it to their own entities, and to not go through the trouble of finding out what exactly, on the consumer side, what happens to the OpenLineage event, then it should be noted which OpenLineage entity maps to which entity on the consumer side. Next one is failure reporting. So we would like to notify the maintainers of the tests about potential failures, but on the other hand, we would like to not do it too much, because if you get notifications that something fails all the time, then you'll just start ignoring it. So we need to have some way to limit that. And the local running, so everything we have should be modular, and so we can just take the part, if somebody wants to run it locally, they can take the repository, like take the parts that validate the OpenLineage event or maybe the consumer and just run it as they need. So yeah, circling back to our repository, it basically contains 3 GitHub action workflows that handle all the scenarios that I mentioned. So we have first the test validating the new tests in APRs. We check whatever was changed. If the change causes any new failures, so the failure that was not before in the report, then we will not let it be merged to the main branch. Other one is the spec changes, and the spec changes is basically we check the OpenLineage main repository for changes in the OpenLineage spec. If we see that the spec was changed, then we will run the tests for producers and the input events that we supply for consumers. And if there are any failures in there, then we would like to notify the maintainers of the scenarios, the developers, that, hey, there is some issue, potentially, maybe backwards incompatible. You should watch it, especially before releasing. And the last one is the new releases workflow. So if there is new version of OpenLineage or any other component, or there are components that are not really versioned, like they are as a service, so we need to just periodically check them. Then for periodical checks of those and any new release of either OpenLineage or some components that uses it, we will run the tests for those components. We will, again, if there are any new failures, we will notify the maintainers of the scenario. And after that, there is the interpretation of the results. So basically, we will get the test reports, and from the test reports, we will have to extract some information. And the test reports are basically JSON files that have, info about what is the component, and the component has a list of test scenarios, and each test scenario has a different singular tests. Each test can be either syntactic tests, so we check in case of producer if the produced event is compliant with the syntax, with the OpenLineage standard, and in case of the consumer, if it can be ingested. And the semantics are, we compare with expected OpenLineage events if what is produced fulfills the expectations. What is also what is used to interpret or compile some results from it is the tags field in the test, because the tags for the consumer, it says from what producer the message came. So this indicates compliance with the producer. And the facets means that the facets, this test shows that the facets were present or were used. For the producer, it's similar with the facets, but the difference here is we have this thing called lineage level. So different data sources can have different lineage level. For example, the dataset lineage level is only that we can identify source table, target table. Column level lineage is we see which column came from which, and transformation is what happened between the source and the target. And for example, for Spark in JDBC, we don't have transformation types. We only have, for JDBC sources, we only have the column level lineage, and that is something that can be pushed through the tags. And we get the reports. We create a summary of that, and based on that, we create something called compatibility tables. And For now, our strategy for compatibility tables is, let's say, lenient because it's only, and binary, because it only says that we either support facet or don't support a facet. And to support a facet, you just need to have one test that supports a facet. So basically, this is the simplest version of the compatibility tables. And we can see that there is a consumer that supports run facet and processing engine facet, and the producer that supports run event, job type, and parent facets, and for the consumer, the available producers and data lineage levels for data sources in producer. So here is the basic overview of our of a structure of a test, and we try to keep it we try to keep all the tests and all the consumer scenarios according to this one. So to make for consumers, to make everything available for all and reusable, we have a separate directory with consumer input events, and that is basically shared between all the possible consumers. And for each consumers, we have the config files for each scenario, maintainers, which of course has a maintainer list, scenario with a description, and a validator or a runner in producer for all the specific files to run this particular test. Because, for example, sometimes you need to spin up some Docker, sometimes you really don't need to do anything if you are using some service, and if you are using some cloud technology, you have to set it up. And yeah, for our implementation goals, we basically did quite a good deal of them. Right now, publishing to the website is still work in progress, and compiling the information is still improved. And of course, like the more scenarios, the better. It's always work in progress. We can always add more. Where to go next? Like, where are we going? So right now we are working on handling multiple versions of the components and OpenLineage in each run. Yeah, so basically that is mostly done. We are trying to move to the website, and we are, like, the more in the future, are developing a way to make the scenarios we produce with the producers to use them in the consumer tests. And more conceptual is how can we extract more information, or maybe what should we also get from the tests to get better insights into compatibility. The last one is, if anybody would like to, join in, then we are welcoming any OpenLineage input events from defined scenarios. I mean, if you would like to make some first contribution at any point, then that would be very much appreciated. And that's basically our overview for compatibility tests. Thank you very much. Questions?
Hey, nice presentation. First question is, you mentioned the triggers of releases, basically. So there is a release of spec and there is a release of some sort of software. Mm-hmm. How do you find that there is something new?
So for any new releases, it's the same thing. We have basically we have one files that they contain the currently latest release, and well, basically while running the jobs with some frequency, we check each time if there was a new release. Like, the assumption is that, for example, you have a Spark release, you don't have to check it exactly. That's hour, minutes. You can just, this day is enough. So we run it periodically, we check the newest version, and unfortunately, it's for a lot of things, it's really custom work, because if you have a Maven artifact, you can use Maven. If you have, like, for example, in OpenLineage, we use GitHub releases. But if something is not in Maven and it's not in GitHub in a way that OpenLineage is, then basically it's a custom stuff.
Okay, and the second question is, I know this is still work in progress, but did you experience that these tests helped? They reach out to the maintainer and help them fix something?
Not yet.
You found some bugs.
I mean, like, I found some bugs myself, because like, while setting up tests for Dataplex and Spark Dataproc, there were some scenarios that provided some insights there. So
Okay.
I helped only myself, but I think it counts.
Okay, thank you.
Any other questions? On the call, anyone?
Sure.
Yeah.
Thank you. On your talk, you mentioned like it's very important to have local run of the test. Why it's so important? Just for developers to be easy to reproduce the test.
Sorry?
During the talk, you mentioned that it's very important to have like local run of the test. Why it's so important?
So once we provide some way of verifying, like, for example, you are, as a, I don't know, some producer, you're producing OpenLineage events, and you would like to just check if it's compatible with the standard. It's definitely easier to, if we provide you with a way to run it locally, then you don't have to, like, for example, in our case, it would be submit a PR with some setup of the infrastructure. Like, there is a lot of stuff to do. It's much easier to just, you know, do the first run on your machine. Also, like, debugging wise, it's always better to run local, because like something is not working and you can just, like, you know, like run it on, like, with a debugger and see exactly where the problem is. Which, for example, if you submitted your file, then you will get some feedback. It will just not be that good, right?
Yeah, but I wonder about some cloud providers services. So it's like not completely local. You still need enable integration with it somehow.
I mean, yes, but like, so the way I think of it as an important is we don't like throw logs under your legs. Because if you were somebody who would like to just check if something works, if it's on the cloud and you have to set up the cloud, that's one thing. But if you have to, like, basically do the whole configuration to fit our framework already, and you just would like to check some stuff, then
Yeah, thank you. Also, I have a question. Do you have like Composer integration already?
no.
Yes? Oh, no. Okay, I got it. Thank you. So, and overall, do I understand correctly? So you provide a set of tests following some standard. So if I want, I can pick some parts of it, check integration, cross integrations between producers and consumers and so on. And also what you showed with GitHub workflows, it's like you have some regular runs to check compatibility between versions. So overall, you might have some dashboard with what compatible and checked. And if you want, you can go deeper and check like everything you need. Is correct?
Yeah.
Thank you.
I mean, like so it's worth mentioning here that whole repository and the project is still pretty fresh. So we do not, like, for example, the composer, we do not have it covered simply because we just haven't get around to it yet, right? So there is, for now, there is a few scenarios that we had to basically check the functionality of the framework itself, and we will add more in time, but it's still we lack a lot.
Okay, thank you.
Thomas, sorry, can you guys hear me in the room?
Yeah.
Hi, Thomas. Dan, as per our conversation last week on the TSC, thank you so much for doing this work. Really, really great stuff. I just want to highlight the conversation we had to the other attendees we had last week around, we're obviously doing a piece of work top down and looking at the publicly available information on status of compliance and plans. And of course, that status is available. I've pushed that to the Slack community. That status is available on Verinode, and I think we'll kind of work out how to push that into the repo as well. The second comment I wanted to make was your last point was super important. I think we certainly need to think about levels of compliance as we spoke about on the TSC, right? Like I loved your point at the end there, right? We don't want to scare people away from the standard because we've bound too tightly to levels of compliance, right? We've got to have, level 1, and we can cut that multiple dimensions by, firing at run facet at the start of the event, for instance, and those factors we talked about at the TSC recently. So I think there's a couple of ways we can think about that, and we can continue the conversation on Slack, but I just really love that idea of levels of compliance and levels of standards met.
Thank you.
Hey, Daniel, Jens here. Thank you for the comments. Actually, there is this proposal doc that Tomasz was showing as well on in his presentation. Maybe you want to have another look at that one. There was a bit of discussion around the levels of compliance or compatibility, actually. So happy to hear your insights on that one.
Sure. That's in the repo, is it?
Yes, it must be available. At least you find it in GitHub on the issues.
Should
Perfect.
be, yeah, issues and proposals.
Yeah. We'll also share the slides most likely after the meetup.
Perfect. But I just want to say thank you again so much for those working on this. This is really important. I was literally having this conversation with a client last night. So fantastic.
Cool. Thank you, Daniel.
Hi. I'm not sure if it fits here, but I was wondering about tests for dataset naming conventions. Did you think it makes sense to have, for example, this consumer accepts all the known naming conventions, datasets types we define in OpenLineage?
So with dataset naming conventions, it's so right now we mainly focused, for the sake of simplicity, we focused more on if we are talking about the consumer, we only go to the level of which producer it was, right? And for specifying for example, the tags. And we, of course, can do multiple scenarios where they are just different data sets defined and constantly periodically check if everything is all right. Just generate those events that are identical, just have different data set names. That's completely viable. But basically, right now we do not have a way to go any further than this because we don't pass the information about the data source used in the consumer test. So we can basically run the test and see if something fails. We just do not have a way yet to reflect it in any compatibility metric that we create.
I just wanted to add that around dataset naming, there is long-standing idea of like letting programming languages and type system do the work, and instead of having like dataset class and name the namespace, have like a BigQuery dataset that would be able to validate actually what data you're providing and output the correct information. Of course, that doesn't solve 100% of the problem, because this only solves it if you use official OpenLineage clients. And of course, anyone can write their own OpenLineage compatible client, and you still would need to validate on consumer side. But I think it would solve most of the problems we see around this. But it's an idea. Nobody has gotten to implement it yet.
Any other questions? All right, cool. Thank you, folks. We'll have some food and drinks over here. We'll return at 7:40 p.m., so in almost 45 minutes from now, and continue then with presentations by Paweł and Maciej. All right, we'll continue then. So Maciej is going first, and then Paweł is following up from that. Two long-time OpenLineage committers. Really exciting talks. Looking forward to that. Go for it, Maciej.
Thank you. So I'm Maciej. I'm a OpenLineage committer, TSC member. I work at Datadog. And when talking to new people about people new to OpenLineage, one of the questions we've always got is how does it relate to OpenTelemetry? I've heard about this. How is it something similar? And we always gave like less than satisfying answers, I think. But okay, this talks about one like lifecycle of a request, and we want to talk about all data sets and how they are produced. But so today I wanted to expand on this and some related topics, like how do we relate to like more traditional, it's not that traditional, but traditional telemetry, observability, and how can we integrate with them? And maybe we'll have time to talk about how to enhance this connection. So I want to talk both about like conceptual insight, and more practical ways to leverage this metadata. So I have like three primary sections to talk about. First is I will introduce those observability concepts and OpenLineage event structure. I will talk about how they relate to each other. And in the third part, I will discuss more practical integration and show some enhancements proposal, maybe. So why do we want to talk about this? So those modern data workflows, like Airflow, connecting to dbt that spawns some other, for example, Spark jobs via Spark adapter, they grow increasingly complex, more distributed, more independent, interdependent. And the teams that debug issues within them have more problems than ever, right? There's limited insight into those pipeline failures, into their performance. And, like time to resolution of those issues is growing longer and longer. So it's even more important than the robust observability provides us the context when we see those failures to enable teams to quickly diagnose the root problem. And I think like integrating OpenLineage into this traditional observability world would help a lot. So what are those observability pillars? And traditionally, they're defined like three observability pillars. We have metrics, we have logs, we have traces, and metrics are those numeric values right? Like CPU usage in percent of or load, memory usage, request rates. It's kind of easy to aggregate and easy to monitor and alert on, right? Logs are those rich, structured or semi-structured records, and you can contain some more detailed context for debugging, right? And traces are kind of representation of execution flow. So they show how different services or tasks interact. And I would add two more, that this data is not very useful if you can visualize it, right? Clearly see how those metrics are across your like server fleet, right? And of course alerting, which lets you know that something is wrong with all of those. But I will talk a bit less about those later two topics. So metrics, right? They provide us with this insight into system health, performance, and other stuff. And we have some numeric values like counts. So just how much stuff has happened since like this Kubernetes pod was spawned. There are different types, right? We have gauges, histograms, distribution metrics, and they are all made to let us visualize what happens easily, right? The strength is definitely in aggregation, right? So you can see an average load across your entire fleet and not see each server's values, for example, separately. And of course, it's very easy to alert on data like that, right? Because you might see average CPU usage across your entire fleet is over 80%. You want to alert somebody on that, or like error rate exceeds 0.7%. So this is kind of the foundation for this modern observability. So then we have logs, and they are basically timestamp events with some precise time context. And they are very useful to understand exactly what happened and when something has happened. So it's important that the structure is way less defined than in the other types of these observability events, because traditionally they were just string values. And modern, of course, cloud-based environments have shown us that it's very important to provide at least some structure to be able to effectively filter them, for example, right? So filter on error logs, filter on logs that happened between this time and this time. And practical examples are like application elements, of course. They can contain stack traces, environment info, unique request info, so you can see exact information about some concrete error. And we have traces, which are hierarchical spans that allow us to capture these interactions between components, right? So single trace is like a view into some global event, let's say. Traditionally, it's thought of like lifecycle of a request, which you can show here. We have some request to shopping cart checkout, and we can see that the system underlying system is doing so much stuff across different contexts. It's not very, I don't know how to zoom. It's not exactly important that we see what exactly happens here, but it calls some other services. It calls database. Maybe if there is some cache, maybe there is some concurrent. I stopped trying to zoom, but they allow us to see the distributed context of the request job. And the important thing here, there are two important things, right? We need to know when something starts and when something ends, and you need to know the context in which it's happening. So there is this propagation, distributed context propagation, which means that to have an effective trace, you have to pass the trace ID, span ID, and parent span ID, which are those three values, to reconstruct the flow explicitly in some backend, right? So we need to know that the Django request here is actually like a child request of some other Rails request. And the use case for that is like latency profiling, diagnosing performance bottlenecks, and there are a lot of great tools that allow you to visualize the traces. So like flame graph as we see here, but also waterfall and maps between different systems. And there is OpenLineage, which we of course all love here. And we are an open source standard designed to capture and share data lineage. We are vendor neutral. We can see people from multiple companies here in this event. A lot of different companies are contributing. And the core idea was to collect this data in runtime, right? Not have some post-factum user-defined process that does not capture the actual execution, but actually integrate with Airflow, Spark, Think, and other systems to know what happens here. We have a tree. We have three core structures, core data structures. I'll talk about them in a minute. And another thing is that OpenLineage format is flexible and extensible. We have seen at the first presentation that Google has no problem attaching some of their own custom metadata to the events generated by the composer. And we want to also do this kind of connection, right? Connect these diverse technologies. So we want to see a lineage between Airflow, Spark, and dbt, and nothing is stopping us from making it this way. So yeah, the event structure, we have run events, we have different events, but those are the most interesting here. We have name, namespace, some unique details about the run. So job is identifying concrete workflow, and run is identifying an execution of workflow. And we have data sets, which identify the data sets, right? So data assets, but they can be different things. There's no problem in tracking something that's like ML models maybe here. And I know some people do that. Yeah, and we can extend all of those core events with some particular information, right? So we can provide as rich context to those events as we want, really. So let's see some real scenario of how the job can break, right? So like we have an Airflow job that triggers a Spark job that processes raw data. And we use the traditional observability here, right? So we can see Airflow spans and metrics. Airflow has open telemetry integration now, I think. So you can see those spans. Spark job successfully completes, and we also have some Spark metrics. But then there's some data quality validation job later. We can see the logs generated from that. But without the lineage data connecting all of those parts and even a Datadog, we have no visibility into the root cause, even if we are deeply integrated with Sparks. So we not see that. My fictitious example here is that the summertime messed some schedule, causing like the last hour of data not to be processed, and that caused the validation error, right? And I think Airflow actually handles that very well right now. So maybe that's not a very good example. But this is a scenario that Lineage would actually help you to see the root cause of that. So yeah, rapid root cause analysis is one of the greatest benefits of connecting data across multiple systems, right? We can see the correlation between system health of some upstream components to data quality later in the path. Reduce time to resolution those issues, fewer outages, and we can detect those issues proactively. So we can leverage the lineage metadata as some other observability systems. And I will talk in a minute, just the next slide, what that means. So integrating OpenLineage into those observability stack allows us to transform how we actually troubleshoot and optimize and manage those data systems. So how does this OpenLineage event align to those observability layers? And my thesis is that they actually are all of those, right? So the events contain like metrics like data, some quantitative, aggregatable, I don't know if that's the word, facets, like data quality information, all counts. We have some logs like data, and those are structured facets, but they have some unstructured information inside. Like we have an error message on facet that captures the actual error in some processing systems, right? Or stack trace even. And the whole structure is kind of trace-like, right? So we have parent-child relationship. We have run hierarchy. We emit the event when job starts, and we emit event when job ends or fails or does something else, right? There are some special cases, right? And so this kind of allows us to see this as a natural fit between those all categories. We can integrate with all of those systems. So let's look at metrics. And we have a couple of natural candidates for being kind of a metric, right? So we have data quality assertions facet that tells us about success failure of some assertions in the data quality system. And we can, of course, alert on that. We can visualize that. Data quality metrics, and example is here, taken from some test job. So it's not very real, but we can see like some data quality information about the data sets and columns inside. Output statistics, which is emitted by Spark integration when something gets written. We know how many rows, files, size metrics. Yeah, and lifestyle type change. So even like creating something, recreating, updating a data set is a metric, right? Creation, modification event. Dataset properties are also metrics. So yeah, row counts, you can track data volume change, and I think I need to, I can just describe, like we have 3 columns, freshness, row count, and size, and we can see like that row count and size increase linearly in this case. So we can monitor that, right? And if the data sets grows too large, I don't know, maybe it should be just a view of the latest week's transactions, and it grows linearly. That means that it contains some other data, right? We can monitor null misses value counts. And what we can do is also track freshness, which we have as on the here. And it kind of oscillates between 2 and 1.6. And this means that maybe the job that updates this metric is kind of running frequently, but only updates like the latest data from some time before, right? It doesn't fetch all the data that has grown, but only like data from 2 hours to 2 hours and a half. That kind of looks like that. And we have some spikes, right? That's natural usually. Yeah. And events themselves are metrics. So OpenLineage complete event with output data sets can act as this implicit dataset freshness metrics, right? If we have a job that updates this data set, we receive the init event. We know that this got updated. Of course, we need to check the output statistics event maybe, if something got written. Another metric is kind of receiving a failed event, right? So we can monitor alert on this failure event that it's an error metric, right? Availability of some systems can be based on the event frequency, and of course, based on this, whether we received or not received in each event, we can do as SLA monitoring. So if we haven't seen that the job has ended and it took us a long time, it means that maybe the job is still running, and we should alert somebody to check it, right? We also have logs like facets, error on facet, environment variables run facet. We have some job metadata facet, and one of those is kind of capturing the documentation description of like Airflow DAC. Yeah, you can surface those as logs as well. And it will provide more context to, for example, your metrics. And yeah, the trace-like structure of OpenLineage events. And we can, it reflects the regular span flow, and the parent-run-child relationships reflect the hierarchical traditional traces structure. So the OpenLineage run ID is kind of the OpenTelemetry's both trace ID and span ID. And this allows us to visualize the OpenLineage as distributed trace event. Provides same observability as the traditional like API type request users have across their workstations right now. So what can you do right now to leverage OpenLineage data? Right, you can translate the lineage to OpenTelemetry and generate a span OpenTelemetry trace. You can export those facets to any metric tool. You can integrate and index those lineage events into some search system like Elasticsearch. And of course, you can visualize this. You combine them with operational metrics coming from other sources, like your native container monitoring, just monitoring, right? So let's look at this first scenario that I shown. There also triggers a Spark job processing this raw data, but this time we can see that this output dataset facets indicates a low amount of rows processes, and that can trigger already a metric-based alert. Still, you didn't resolve this in time, maybe, or maybe this job runs again. So we can see that the validation job, downstream validation job, will generate an error facet, and you can also alert on that and show this in the same view. And thanks to the parent run facet that we have, we can clearly connect all of those, right, to the original workflow. And system like that, compared to the original one, where the integration of observability is spread out, will allow the data teams to way easier solve the issue. So maybe a few more practical hints is like we have some facets that allow you to easily add context to OpenLineage events. They are in the latest releases, and the environment facet I think is even maybe a year or two old. So tags facet can capture both system-defined and user-defined metadata added to lineage events. And compared to traditional like key value structure of tags, we also have a source field, so we can see whether like this tag came from Airflow, users setting stuff on Airflow tags, or like because somebody said it in a config and it's coming from. And the environment variable room facet captures runtime environment details, of course, but this is also kind of user-defined. We don't want to capture whole environment of the user because that would capture a lot of stuff that we don't want to capture. So user can define what actually environment variable can be captured, and we attach them to the run facets. So this also simplifies correlation between different events and can provide you with additional context, like the environment you're in, who owns the pipeline, for example, right? If we didn't capture this in ownership job facet. Yeah, and then if you have some integration, you can visualize OpenLineage metadata in dashboards along infrastructure health. Yeah, integrate all of this data, and this is like a small example of a trace that unfortunately didn't fit very well into the screen, but this is a DBT job being DBT job information being visualized from OpenLineage data. So you can see, for example, I don't know how to scroll there, but you can see that stuff is running on parallel, and we have some sub-child jobs doing stuff like begin takes, I think, surprisingly large amount of time on Snowflake. That's one thing you can learn easily from OpenLineage data. Sure. So what can we do? Maybe we should deepen the integration of OpenTelemetry and tracing standard to make this context switching between lineage and tracing easier. One thing that OpenTelemetry does is they have kind of a semantic naming convention, defined semantic. So like you'd name this, I don't know, Java Spring Jobs the same way in different integrations. And maybe we should think about it in the OpenLineage context. Standardize some specific integration data, right? So, for example, the Airflow task ID should be always passed in the same similar way, so that the clients know what to expect, even if it's not in some particular field, in some particular facet that has standardized field. Maybe this should always be defined in some way, the same way that we define data sets. We don't enforce this yet in dataset case, but maybe in this we shouldn't also. Right, additional integrations, of course, the more the better. And we should maybe think of adding additional facets data to allow for a better correlation. And I don't think we have time for bonus slides, so I will just ask you for that question.
Hi, Maciej, great presentation. What are the drawbacks or potential issues with converting OpenLineage into OpenTelemetry?
Potential issues is that you can do it wrong, right? When there is some data, for example. But I'm not aware of a drawback per se, right? Maybe I would think of how easy or hard it is, rather than maybe you don't get anything from it because you can't visualize traces, right? That kind of stuff.
So let's speak about an example. Assume I have a job that writes to a data set, and then there are like hundreds of other jobs reading from this data set. Will this be represented? So, you know, in OpenLineage, it's a graph with hundreds of edges, but they don't have to share the same trace or span ID. Will it work the same in OpenTelemetry?
Yeah, so no, it's a different, it's like a horizontal versus vertical view, right? And the way we are talking about usually in OpenLineage visualizing lineage graph, we have this data set to job to data set view. But what I want to emphasize is that the trace view of the same thing is like showing the job and whatever spawned it, so like parent-run relationship in a trace, rather than what happens if after you write this data set and what reads them. So this would be complete separate trace in my view, right? So if you have one job that writes the data set and you have 100 jobs reading from this data set, you will have 101 traces, right? Okay, thanks.
Any questions from the hybrid audience?
Yeah, if we may.
Yeah, go ahead.
Hi, Maciej. Thank you very much for the presentation and great thinking. We've been thinking at Bearing Note about the differences and similarities between these two requirements. And somebody in the room asked it, but I'm just wondering if you can go back to it. Like the thinking between the different requirements DevOps teams have with regards to managing incidents, outages, and the differentiation between data ops teams and the requirements they have for managing incidents. That's one. You talked about the multi-dimensional nature of the problem. So that ops type question is there. But I'm also wondering about the top end, right? At the, at the right-hand side of that consumption, at the user end, and what that means for the consumers of the services. So a consumer of Docker service that's being monitored is very different to a consumer of a data set in a dashboard. I'm wondering if you just think through that supply chain, if you like, of services.
Yeah, so when talking about consumers of the data, right, and BI tools, dashboards for data, stuff like that, I wouldn't necessarily connect those two unless we think about instrumenting some of those tools, right? We have this traditional lineage view, right? And it fits very well into this ecosystem. We don't need to do anything except maybe making OpenLineage better by itself. But the view I presented here is kind of this operational view, right? And not everyone needs this. And I think the overall view that OpenLineage has, which is we connect the job producers with like consumers of the data sets, producers of the data sets, and in between, is working well enough for this use case, right?
Great. Thank you very much. And again, thank you for the
But
presentation.
yeah, we definitely miss some BI and this type of integrations in the ecosystem.
Look, I think it's going to get interesting in the next little while, right? Because you're right. Human consumption is one thing. So BI and visualization. I think as AI agents consume that data more and more, right? How are we tracking that consumption? I think is an open question as well.
Definitely.
Any other last question?
Okay, thanks.
Hello. How are you doing? It's sleepy? I mean, it's 8 already. Yeah, I don't know how. So I will try to show some code. So if some folks from the behind of the room would like to step closer, then yeah, it's the only chance to see the things I will present. And thank you all for coming. So I didn't expect that many people. Actually, I thought, being the last on the agenda, Maciej would take all my time and I would just say, oh, I didn't manage. So I didn't prepare any slides, but it didn't work out. Thank you for having me here. Thank you for organizing this. And yeah, I will have also talk about metrics, actually. I didn't synchronize with Maciej, but I will have a demo, so totally different point of view. And I refurbished my presentation title too with ChatGPT help to something more jazzy so that you don't fall asleep. So my name is Paweł Leszczynski. I'm software engineer at GetInData and already working for like 3 years with OpenLineage. And it's great time to be able to work with open source for big companies and help them use OpenLineage within their environment. Yeah, we'll start with a demo and 2 types of metrics, because if you go to the OpenLineage.io site and you type metrics, you're going to see some operational internal metrics, and this is something I would like to describe briefly first, and then we'll go to the demo of the New York taxi data available and see what real problems can be solved with OpenLineage and some metrics extracted out of the events. Yeah, I hope you like it. The demo is available on the GitHub, so Tomasz, please check if the QR code is working. And if so, you can run just the Docker Compose app and yeah, work with this. So the demo will go through the 3 tables. So first one is a yellow trip data. It's some taxi rides and it contains ride ID field. Then I manually created the user reviews table for a fraction of the rides with some textual review of the ride, and it also contains ride ID. And then on the top of it, we would like to do some monthly aggregates. It's the 3rd table. Yeah, so we can start with OpenLineage operational metrics, and this is something that Maciej introduced last year, but I think people don't ask about it on Slack, so perhaps they don't know about it. So I think it's good to go through this. So it's very useful in monitoring OpenLineage connector. It's used within Spark integration. So I'm mostly working with Spark and Flink integration. I'm the Java guy. So the things I will describe here refer mostly to this. So it's really helpful to answer the question like, how long does it take to generate some OpenLineage event? What are the timers? It can be also used to monitor time spent on each visitor, so some part of the Spark integration code base. So if you think your OpenLineage integration takes way too long to generate the event, definitely try looking into this, and there's a great chance you'll find the cause. And it's based on micrometer library, which is similar to SLF4J. Yeah, so it's useful to debug things, and if you turn on the debug facet in the OpenLineage integration, then you'll get it by default. So as being said, it's based on the micrometer.io. It's a vendor-neutral application observability facade. So yeah, it's similar to SL4J. So imagine there are dozens of backends where you want to send your metrics, and you don't want to have dependencies to all of them within your jar because it will be a lot. So you have like a tiny jar with the interfaces, which you're going to use within your code. And then if you want to use some concrete backend, you attach another dependency to this specific backend. So it prevents you from vendor lock-in, and yeah, it's really comfortable to use. So the OpenLineage, Spark OpenLineage integration code is, has in many places injected the code snippets like this. So there are like counters that you can increment. There is some timer that, given the Lambda, measures how long did it take to execute that Lambda. There's a gauge also possible, but actually I think we're not using this at the moment. And the meter registry is available within OpenLineage context. And OpenLineage context is a class that is an object that's available almost everywhere. So whenever you are trying to implement something custom, have some issue, yeah, you can easily add more of them. And yeah, actually, currently only the statsd meter registry is implemented. If you want to implement any other backends, you need to add some reflection that loads the classes. It's within the documentation, yeah. So yeah, you need to add some trick to make it work. So let's go to the demo. Do you see the code? Oh, it's not that bad. I would say it's, yeah, if you sit next to the ends, it's great. So the demo, yeah, starts Jupyter notebooks and also starts Marquez. We should have an empty Marquez. Marquez is our reference backend architecture implementation. Yeah, it's the place where you can simply send the events. And we start by creating the Spark session. And we use OpenLineage Spark integration. Actually, I use the one built from the main branch. We'll also add this iceberg connector. Yeah, we define OpenLineage listener. We tell it to emit events into Marquez. And then we add some information about the job ownership. So some time ago, I worked with Tomasz, who is also in this room, and he has a rule that he names all the teams he works in as capybaras. So yeah, it stick to my head. It's drilled somewhere deep. So whenever I need to provide an example team name, I call it capybaras. And we also configured the iceberg catalog. Okay, so once this is started, we will download, actually I will not download, but this thing is downloaded the New York Taxi trip data for the year, I think it's 2024, except for November, which I skipped deliberately because we'll need it for the later part. And yeah, and we actually do some kind of partitioning of this table. We partition it by a month and add an extra column, extra field with the month. And we'll have a scenario which is pretty common nowadays, that we have a table with plenty of date time fields, like when the trip was started, when the trip was completed, when the trip was in the middle, and the event was registered some proxy. It's a common scenario that you have a lot of date time fields in your table, and you use them for filtering purpose, but you can use them wrong, because some are used as partitioning fields, some are not. And yeah, actually, I think it's enough to go to Marquez and refresh it and see that we have some events. There is something started and running, and within the Marquez, it's easy to look the JSONs, and there are the run facets, and one of them is the debug facet, and it has the metrics that led us here to listen to this presentation. So yeah, these are the metrics that are collected, and most of them they are like values, and this one is called execution time, and another will be called also execution time. But if you look at their tags, you'll see that they represent the facet builders that took some time to get computed, and the value is in the microseconds because it's the time unit that suits best into this purpose. Yeah. So for every part of the integration that creates some facets, you can have such metrics. And if you think that OpenLineage event generation takes way too long, please take a look at them, because there's a great chance that one of them will be a way bigger. Yeah, one of the metrics here is the free memory ratio. It's good to look at the code to know how it is computed in the Java world, but yeah, you can have more of interesting things here that are useful if you want to debug OpenLineage integration. Okay, I think it's time to, do you have any questions related to this part? Maciej, you can have one, you can have it later. It's, oh, he's okay, we can proceed. And now, so this was important because, you know, if you go to OpenLineage.io site, you search for metrics, you'll get a lot of information of this internal metrics. And there are also metrics related with facets, which actually Maciej had on his slide before. And within the spec, we do have something like the input facets and output facets. And I would say it's something in between the run and the dataset. It's like a facet describing dataset in the context of a given run. These cannot be run facets because they can describe one of many facets involved in the job. But these are not also the dataset facets because they make only sense in the context of a particular run. And as an example, you can think of this like the amount of rows or bytes read and written by a job. And yeah, this can be also metrics coming from third-party libraries like Iceberg. Yeah, as of Iceberg 1.1.0, it supports metrics reporter and the metrics report API. And there are like two interesting type of metrics exposed: a scan report that carries metrics collected during the scan planning against a given table, and commit report, which collected after committing changes to a table. And Iceberg also has a REST metrics reporter, which allows you to send the metrics wherever you like to an endpoint, but you can also create a custom metrics reporter. And this is something we actually did. And we implemented OpenLineage metrics reporter that we automatically inject into the running Spark app. And then we correlate those metrics with OpenLineage events. So the example of commit report, it's from the Iceberg documentation. There are like some commit metrics like the total records, amount of files being written, lots of things that perhaps you may find interesting. And yeah, this makes us go back again to a demo. Did we save this? We can save it one more time. So yeah, we create the yellow trip data table, and we also create the user comments, which has some string, and yeah, it's also contains the RIND ID so that we can join it later. Yeah, and there's a common pitfall that I've seen many times before. So imagine you do have two tables with that you can filter through the event time, and you want to join them. And the common pitfall is that if you do the filtering only on a single table, then yeah, the results will be correct. It's just that it will take a way too long to execute. So in this case, we are filtering comments based on the month, but we're actually not applying the filter on the yellow trip data, which means if the table, so we are interested in a single month and we are scanning whole table that can be, yeah, that can be really big. So we're doing the live demo. Let's see if we can make it. So what we can do once this completes is we would like to try to identify the problematic jobs and contact the teams. And for this purpose, we'll use Marquez and get the events that we submitted to Marquez and try to do some scripting to identify the jobs that contain the problem. I think we are done with this. Let's go with the next one. And and then we can go to the Marquez. So, these are the few lines of the scripting code, and perhaps you can do a tool with a shiny UI that does it better. But what it actually does, it goes through the lineage events, and within the Marquez, you've got the lineage events from all the jobs within the organization, and you do you look at the iceberg scan metrics, and there's a simple rule implemented. If the job has read more than 1 gigabyte of data and there are no skipped files, then let's get those guys on the screen. And I think that you can be creative and invent many other useful tools, useful scripts for doing similar thing. If a job reads more than 1 terabyte of data and it's not skipping any files, perhaps there's something wrong with it. You can try to identify it, and and we identified the capybaras. So we can get an email and go to capybaras. Hey guys, how are you doing in your muddy puddles? Is this job correct? Do you really want to read that amount of data without having the skipped files? Because if you're using Iceberg and the table is partitioned, and if you are doing some partition filtering, the skipped files will be greater than 0. And this is something that OpenLineage gets useful because, we're able to write a rule. We can create more rules with AI, and having the ownership information, we can go to the team and ask them if this is what they wanted. But actually you can say, hey, the same problem can be solved without OpenLineage, because you can get the iceberg metrics and you can iterate through the iceberg metrics, and you don't have to apply OpenLineage here to have this done. It's just the OpenLineage serves as a transport for the iceberg metrics, and perhaps you can do it other ways. So let's see the other problem, like the missing November data. So as we were importing the data, we didn't import the November, and we generate we append data to a table, and when looking at the metrics at the Marquez, we can find out that there was a job that has written just 1 record, probably some trash at the input, and it's weird because it's been writing like 37,000 records each month. So we see there is it behaves differently now than it used to behave previously. And this is something that, so there's a problem. Job was writing that amount of rows, and now it changed. The amount of rows written changed, is close to 0. And with the help of OpenLineage events, we can identify this job, iterate through it, and find out all of its inputs. And we can see that, before the same job was reading a lot of input rows, and this time it's reading a limited amount of rows. So this is interesting because in this case, OpenLineage allowed us to correlate the broken output with the missing input. And this is because we're able to synchronize the commit report with the scan report. And I'm claiming this is the real value that OpenLineage is bringing here. So why this is so important? I think it's important because with the help of OpenLineage, although we have 3 tables and we have scan reports for each of them that we are reading and the commit report for one that we are writing, with the help of OpenLineage, we are able to correlate the commits with the scans. And if we see there's a problem with commit, we can find out which scans were related to this. and try to figure out if this is affected. So if those scans affect the commit. So the cool thing about ChatGPT is that, my favorite movie is Big Lebowski. I know you've seen it. If you didn't, definitely worth spending time. So I've asked ChatGPT what would Jeffrey Lebowski tell about OpenLineage. And yeah, I gave him a hint. I gave it a hint that OpenLineage is more than governance. And there are a few nice things, like it's about empowering folks to really understand their data journeys. And the even better one is OpenLineage is helping people groove with their data, not just govern it. And that's so silly, I like it. So I think that OpenLineage, is frequently advertised as a way to, as a solution for the compliance regulations and data governance. But what is often missed, is that it's actually a tool that allows you to solve real, everyday, practical problems of data practitioners. So it's not only about drawing the graph, which you have the inputs and the outputs, but it's like the understanding how the inputs affect the outputs and, solving the problem that you have. So I would say that if there's one thing that I would like you to argue with me or remember after this talk, is that OpenLineage is more than data governance, and that I was able to implement few rules with 5 lines of Python code. And if you made AI to invent such rules, it would have done it way better, and it could generate dozens of them. And the other interesting thing is that AI will not be able to improve your jobs without metrics or OpenLineage events, because it's not that you show the SQL and something will be able to tell you, hey, the SQL can be written in a more efficient way. It needs metrics. It needs to know that something is wrong. Your query is reading way too many rows than it should. And then, you can tune it better. That's the last slide. Thank you very much for having me here. And do you have any questions?
Thanks, Paweł, for the talk. I agree that metrics are great. Do you have an idea how we can get more of them?
How we can get more of them?
More of them in more contexts.
Yeah, I mean, the iceberg metrics are great because we can get them for free. So we have another community that is exposing the metrics, and we just enrich OpenLineage events with what we have. So I saw you had like interesting metrics on your slide, like the distincts and so on. I was wondering, how did you take it? Can be. So with the pure Spark, it's not that easy because the input and output metrics are collected from the tasks. So the Spark tasks, we know how many records or bytes have been read or written. But I have not found any more interesting metrics there. It doesn't mean there are not, but yeah, I tried sometime and these are the best. So I don't think there will be like general purpose Spark available metrics, but there can be the backend specific, catalog specific, so data source, data format specific, or data format specific, yeah.
Any other questions? Virtual audience? No? Thank you, Paweł.
Cool. Thank you.
And thanks again to all the presenters today. Thank you for making the effort and sharing, like deep insights about OpenLineage. Very cool. I think this time we were even more folks than last time around at this meetup. So also thank you very much for everyone who joined, attended, asking good questions, and hope to see you again next time. As I said earlier, those GetInData folks are inviting for some drinks and snacks at Uwaga Pivo. I guess a few of you folks will join and walk over there. Otherwise, anyway, we will slowly all move out of this building now. So please, take your stuff and move downstairs, and then we can group there. Thank you so much.